Hi, this is my presentation video as part of my design submission for the Beyond the Phone Challenge of Element 14. We were supposed to design an application where wireless charging can be used, and I would like to thank Worth Electronics, Texas Instruments, and Element 14 for the opportunity. In this video, I'll be demonstrating and explaining what I've done for the challenge and how I've implemented my design. Now, I've already done a preliminary video for explaining what my design is and why it is, so I'm not gonna explain the entire block diagram. I'm just gonna explain what I've done. Essentially, the requirement for wireless charging in this particular project is because my electronics is supposed to be concealed. By that, what I mean is I have a demonstration box here, and this box is supposed to contain my perishable materials like fruits or flowers that are supposed to be transported across a continent over a ship or some other method. Now, my system, essentially what it's doing is the crate box lid is basically the housing for my electronics. Now you can, because this is a transparent box and I had to access the electronics, it's a demo system, but the essentiality of it is that I have the electronics concealed within the lid. Now it has the temperature sensor, the switch, and the wireless transmitter, the controller, and the wireless charging solution all built into the hatch. So nobody is actually able to access this unless somebody says, you know what, the batteries are now damaged and I have to replace them, and so that's going to be a costing. But beyond that, really it's not supposed to be accessed by anybody else. Right now, this is the condition in which I have the perishable materials inside the box and the crate is operating, and it's basically transmitting over XB the data from not only the sensors, that's the temperature sensor and the switch, but it's also transmitting the information regarding the battery status, how much time it's going to take, and some other parameters. And I can actually add more parameters such as accelerometer data or something like that. After it's updating it over XB over to my BeagleBone. This is just a display attached to the BeagleBone. It's an HDMI display I got off from an online vendor. Now, I tried to use the MSP430 RF system. Unfortunately, one of my students has a project deadline, so he borrowed it. So instead of using an MSP for CC2500 module, instead of that I'm using an XB module. My first goal was to use all Worth Electronics and Texas Instruments parts since they're my sponsors, but unfortunately the only module that I had to buy out was the XB. So right now what it's doing is it's taking information regarding the temperature sensor and the switch data and the battery information, and it is transporting that information via XB over to the BeagleBone Black via a custom framing system. I've already put the code online on GitHub. It's for free to access for anybody who was interested in looking at what code I did. All the scripts, including the Python script, the PHP scripts that I'm going to discuss, and the code for the Energia for the MSP430, all of that has been put on the GitHub site, so most welcome to access it and contribute if you'd like. So let's take a look at what happens when we take the crate out, the lid off of the crate. Alright, so right now, as you can see, the Python application is basically telling me that the system is discharging. The time to MD is about 268 minutes. The temperature is 34 degrees Celsius. Yes, that's right, that's the temperature of my office right now. So when the lid is on the crate, it's telling me switch is at a 5-second delay. There we go. The switch is now 1. That means it's telling me that the crate is closed, and you can see that the crate is closed. There we go. That's okay. Now, as soon as I take the lid off of the crate, it tells me switch has now turned to 0. Right? Okay. As soon as I put it on my charging port, now what happens is the messages will start. Oh, the system is charging. It need not actually, it's still sending all the data, but it doesn't display it. Now the number it says is 65,523 minutes charging, full charge. Actually that's wrong. There's something, I think, or I messed with the code or something or the other. I invite anybody who wants to debug, most welcome. But yeah, there is some kind of an problem there, but at least it's able to detect whether it's charging or discharging as soon as you take it off of the charging port. Now it's, again, the temperature has risen from my office, and now it's 34 degrees Celsius at 12 in the morning. Alright, so here you can see that the system is working. It's talking to my BeagleBone Black, and it's basically telling me that I have a temperature of 32 degrees. The data is sent basically after every 5 seconds. There is a switch which tells it whether it's inside the crate or not. So if I keep the switch closed for using my hand, and there we go, you can see that there's a switch 1 status, and as soon as I let it go, it comes out to be, let me just zoom in a bit if I can, there we go. Now as soon as, if I hold it down, the click sound is basically the switch, and there we go, and if I let it go, there we go. So that's about how the system reads status. Alright, now what happens when I have to charge it? So it's really simple. Just put the crate lid where it should be, and there we go. It says system is now charging. I'm just gonna move this inwards, now you can see, and no. So yeah, there's my system charging, and beyond that, I mean, I really don't have to mess around with a lot of things. The extra pegs on the extra screwed pegs form for a base, and as you can see, I can't really visualize where I'm positioning it, so it's a coil is almost aligned with it, and it's charging without any problems. So let's take a look inside the electronics for the crate lid. I've used the module that was included in the wireless design kit from Worth Electronics. Now people have actually done a board design of this whole thing, but the IC inside is very small. I didn't think that I would get all the stuff done in time, so I didn't mess with that. Instead, what I've done is I've used the module that was supplied with the kit itself, and I've just put it in this particular frame thing, so I can just slide it in and out of them. It's just for convenience. It doesn't actually hold a practical, it has any practical significance. Now this is the MSP430 F5529 evaluation kit. Okay, this is something that I got from Element 14 for a different road test. In addition to that, now I have a booster pack. I've done a review of this. This is the MSP430 booster pack. It's basically a battery charging, discharging. And that I have an XB module, and I've got the sensors. That's a little switch, and I've used an LM35. You can use any temperature sensor. I also have a TMP 36. I could have used that, but I just wanted to keep it simple right now. And the bottom board is basically just a connector board, and that's about it. There's nothing actually under this. All I have to do is, if I'm working on it, slide it out, and I want to test it, just slide it back in, and I'm ready to go. I'd like to explain is the Python script running on the BeagleBone Black. Now I'm using a wireless keyboard. I have only one USB port. I tried to use the Edimax Wi-Fi module, but somehow it didn't work out. I also requested Element 14 as part of my budget to send me CC3000 module. Unfortunately, because of some import problems, it never arrived. Now, taking a look at the script, all I've done basically is I have a frame format which has a start and end byte, and I'm just using simply two parts of the script, just searching for the end of a frame and then moving on to waiting for a new frame, capture an entire frame. If I get everything within the frame, then I check the start of the frame, end of the frame. Now, I'm not a programming person. I'm actually an electronics engineer. I'm not a programmer by profession. So I've just dabbled a little bit of code. This code is available at GitHub for anybody who wants to experiment with this, change the code. Please contribute, because you guys can make this a lot better. The ultimate objective that I had was to transmit all this data via GPRS to a server sitting somewhere. I've already written the server script, which is basically a Python script which takes data via GET requests and puts it in a database. I've put that on the GitHub system as well, but since it has nothing to do with wireless charging, so I'm not actually demoing that right now. In addition to that, I also received a GPS module a couple of days ago. I couldn't interface it with the BeagleBone. I think it's gonna be quite interesting to see what I can do with that, but I'll do that as a follow-up to this particular video. I'm thinking that's gonna happen. It's gonna take some time, so that's about it right now. So that's about it. I've tried to implement a design which has the practical implication where you have some certain electronics you don't want fiddled around with. You don't want the electronics to be actually exposed to physically to any person who can tamper with it. So you can use the electronics and communicate with the electronics wirelessly, monitor the electronics wirelessly, have an interface or a head wirelessly. But the problem was the battery. Here, the Würth Electronics battery wireless battery charging solution can come handy, because the system is now completely and totally wireless. You don't need to connect a USB cable to charge the system, and that's about it. So thanks for watching, and if you like what I did, please vote for me. Thank you.